structural engineers who design steel structures, especially steel frame structures, they need to deal with connections because we have all these beams and columns, right? So when it comes to type of the connection, we typically go with simple or moment connections. And the only way to analyze and get the real behavior of those connections is to go to finite element or very detailed modeling. This software and that we used, also the book, provides some guidance about how we can easily figure out the capacities of those connections. So I think it's a great way to calculate the capacities of connections without spending too much time as a practicing engineer if you are designing a steel structure. So I will say, well, maybe as a general, any structural engineering student who is interested in practicing will definitely benefit from this book.
And maybe to add a little bit of things to what Halil mentioned, I believe mechanical engineering student as well as material science students may also be able to get a lot of information from that book because, for example, machine design course, we teach a student how to calculate the strength of bolt and weld and things like that. So I guess in that sense, that book could be basically utilized by them as well. Actually, when we prepared that book, as you know, our book has like 18, 19 different chapters, and each university focused on basically basic and in some sense, some advanced connections. And we found out that actually there is a consistency among all of us, and we were able to verify and validate most of the connections according to the US standards.
One thing I can add is the speed at which this method works. I think that's the most surprising thing to me. We were in a unique position at OSU because I'm on the structural engineering side, on the practical aspects, and we try to avoid finite element modeling and analysis as much as possible. It is so time consuming, versus Dr. Nassiri is on the finite element side, and he spent many hours to run the analysis versus with the method that we used. You just click the button in a minute or two, you get the results. I think the surprising thing to me was the speed that we were able to get out of this analysis.
Yes, and although this is a, let's say, 2D finite element model, we get enough accuracy as well. I guess that's another thing that surprised me very well.
Well, I prefer moment connections. They are stronger, better, especially for this book in the nonlinear range. We can dissipate a lot of energy. That's excellent, but it's expensive, right? So that's the reason, other than maybe high seismic regions or west coast of US, engineers do not, or owners do not prefer it. The region where we live, most structures have very simple connections, limited moment resistance. That makes sense because we don't have those natural disasters like hurricanes or earthquakes. So just because of, I prefer moment connections, but because of the cost, we cannot or we don't use in this area. But depending on the need, the engineers go either to simple connections, they are cheap if there's no need, versus if the structure is critical. Even in places like Ohio, I strongly recommend moment connections, and this book will be an excellent resource for moment connections, because suddenly, as soon as you go to the moment connections, you have to think about the nonlinear behavior.
I agree with Halil. I really like pre-qualified moment connection as well. In particular, I like WUFB, welded unenforced flange bolted web. Because of all those complexity, we have combination of basically bolts and welds. So in that sense, I really like that. I would say, science and technology changing so fast. I would say, I would write actually, always make sure you understand the fundamentals. If you don't understand the fundamentals, you cannot catch up. So I would say, learn fundamentals very well.
Regarding that, probably shear and torsion may be an issue for a book, right? Versus with under axial stresses, probably it's going to do quite well. Bending, I will assume it's going to do quite well.
And the fact that our book potentially gonna has like a hardcover.
Yeah.
So that's gonna help, I guess.
Oh, that's another one. If it is hardcover,
Yeah,
it
it's
should
gonna
be
help
quite
in
well.
blending.
But with shear, I can imagine I can kind of tear it off. I will say this book will be the weakest in shear.